everyone. In this section, we will look into the dissection of TLS 1.2 protocol. The point number one is I want to go into TLS 1.3. That is the main topic. But to understand TLS 1.3, we need to understand TLS 1.2 better. So in this session, we will understand TLS 1.2 better. After the end of this session, anyone can explain to their friends or to their colleagues how the TLS 1.2 protocol works. Okay, I have spent huge amount of time in reading the RFCs, looking into lot of YouTube videos, lot of blogs on how TLS 1.2 protocol works, and my main goal is to present everything within 10 to 15 minutes of time. The point number three is why am I doing this video? I am doing this video because of two reasons. One, this would be very helpful for the college students who want to understand TLS 1.2. And the second important thing is this would be a very important videos for the engineers who are attending the system design interviews. Disclaimer, I'm not using any of my company's resource or any of my company's internal property or any code or nothing will be used here. Whatever I am trying to explain to you guys is via the RFC protocol, which is freely available in the website. So I will just also show to you what RFCs that I have looked into to present to prepare for this presentation. I spent huge amount of time in reading this RFC 5246. So whatever I am trying to explain to you guys is via this RFC protocol. Saying that, let's quickly jump into the uh, presentation of the TLS 1.2 protocol. So I will try to explain and then go into the Wireshark and see the packet flow. Okay. So the very important thing first I wanted to explain to you guys is like if you see here, there is a browser and then there is a server. So on the server, you see there would be a private key and then the public key. The public key would be inside the certificate. The server will get the certificate for it from the root, some certificate authority. And this public key will be shared to the browser. Like public key means public to anyone. Anyone can use that key. Now the first message which moves from browser to a server is a client hello message. A client hello message contains lot of fields, but out of that the very important fields are the versions, the TLS version number that client wants to use to make a connection. So this is the highest version supported by the client. It's basically it is saying that, hey server, can we use TLS 1.2 to make a connection? So it just puts 1.2 to the version and just makes sends that packet to the server. Along with this version field, it also sends the random number byte. It is like a 32-byte random number that is used to calculate the master secret key. Along with this random number, it will also send the session ID, a unique number that is used by the client to identify the session. Along with that, there would be a cipher suits. It's a list of cipher suit that would contain the key exchange algorithm, the bulk encryption, and the MAC algorithm, and then the pseudo random function. We will look into it later on. And along with that, it would be having some extension fields. There are a lot of extension field which kept on adding. Like I won't concentrate on this part, but my main goal is to look into this field. So once this client hello message reaches the server, what server does is the server will send his version number. So it says, hey, this is my version number. Based on your version number, let's use TLS 1.2. And it also sends the random byte. Hey, client, let's use this random number for generating the master secret key. And it will also send, let's use this session ID, which we will use this for this session. And then it will select the cipher suit from the list of cipher suit that the client has sent. Along with that, it will send the other extension fields. Now, the client has a random number which it would have generated. It has the version number. It has the random number which it got from the server. And then it has the session ID which it got from the server. and then it got the cipher suit that the server selected from the list of the cipher suit. The same would be on the server side. The random number which it got from the client, the version number which it got from the browser, and then the random number which it this had generated, and then there would be a session ID what the server would have been generated, and then there would be a cipher suit which it has selected. So the client hello is done, the server hello is done. Let's look into the packet tracer. If you look here, the client hello message, if I click on this client hello message, there is only handshake protocol. In this, you see that there would be a version, which I told to you, a 32-byte random number, which I told to you, a session ID, which would be used by the client for making the renegotiation, and then the list of cipher suit that it has sent to the server. Now, the server will get that message, and then the server will send the server hello message. So if you look here, the server, it selected the version TLS 1.2. It generated its own random number. If you look here, the previously generated random number is this, but here it generated a new random number and a new session ID, and it is telling, hey, use this session ID. And from this list of cipher suit what the client has sent, it selected the strongest cipher suit and sent that request to the server. Along with that, it has an extension field, which I don't want to concentrate now. So here, if you look, the TLS protocol, this is the one which is used to make the connection and the handshake connection. And then it is the next important thing is the ECDSA and then the RSA. This is nothing but which is used to make the key exchange algorithm that is using. And AES 256 GCM is used for the bulk encryption, and SHA-384 is used for the MAC generation. So once this has sent, the server hello is done. If you see below, there are other messages what server would have sent. Like I just went one step further. So client hello, server hello, then the client will send its certificate. So in that certificate, it would be having the public key. So it extracts the public key from the server. Now the client has all this field which it has received from the server. Now I just went into that thing. I minimized the server hello message and then I maximize the certificate message. And if you see here, it sent the certificates. So this is signed by this root CA. Now once this certificate is received by the client will extract the public key. And the next message what the server will send is a server status. So this three message is an optional message. We won't concentrate more on this part. In some messages, you see that there won't be server key exchange at all. So this is an optional field, but the server status field, like the client is done, I'll repeat server allow random number, it sent all this information, it got all this information from the server. So the client, the certificate exchange is done. Once the certificate exchange is done, it sent the certificate status, the OCSP message. The certificate status message is like it tells that whether the certificate sent by the server is a valid certificate or not. It's like this. Hey client, here is the optional proof that my certificate is valid and as provided by the OSCP server. So if you look, once the certificate status is done, it will send the server done message. So if you see here, the certificate status is done, the OCSP message has been sent, and then it says that this is the valid certificate. After that, there is a server key exchange and server hello done, which is an optional field. I will spend little bit of time on the server key exchange. The server key exchange message, this is an optional message message sent between a client. If the certificate provided by the server, whatever the certificate which has been provided by the server, is not sufficient for a client to exchange the pre-master secret key. Whenever a client, I we have still not yet gone to the pre-master secret key, but whenever there is not sufficient information by the client, then the server key exchange message is sent. Okay, this is like whenever you use DHE, DS, DHE RSA, or DHE anonymous, then the key is used by the client to encrypt the client exchange part. Okay. Now the client server key exchange is done. Once the server key exchange is done, then what it does is it sends the another optional field called as server hello done. Once the server hello message is done, it's like the server hello complete is done, right? Like when I click on it, there would be server hello done message. Now what happens here is the client has received all this message. Now the next message which goes from the browser to the server is a pre-master secret key. What is this pre-master secret key? A pre-master secret key is nothing but a 32-byte random number which would be generated by the client and encrypted with the server public key. The server can then decrypt it by using its private key. It's like this. Hey server, here is my pre-master key. Now you should be able to compute the actual master key, or like now you should be able to generate your pre-master secret key. So it sends this pre-master actual master key. It sends that pre-master secret key to the server. The server will decrypt it and receives the pre-master secret key. Now the pre-master secret key is done. Once this is done, what happens is from the what is this pre-master secret key? Before I go on to this part, the pre-master secret key, let's look into it. A pre-master secret key. I just read about this part. A pre-master secret key is nothing but this is a message always sent by the client, and it is nothing but a string of R of 46 random byte. So it is nothing but a 46 random byte which is generated by the client. So now the pre-master secret key, random key has been generated. Now let's go one step further. I got the pre-master secret key. The server received the pre-master secret key. From the pre-master secret key, it generates the master secret key. The pre-master secret key plus the random number which it has received from the server, and plus the random number what it has, plus there would be one more message, and then they compute the hash of it and then generate a master secret key. The same would be generated on the server. There would be a pre-master secret key which it would have been already received, a random number key which it would have generated, a random number key which it got from the client, and then the secret key, and then the master and some string, and then that master secret key would be generated. Now let's see how this master secret key is generated. Now we went one step further. The computing of the pre-master secret key should be deleted from the master secret key is like prf, the random function. It is taking the pre-master secret key plus some string which is with the name master secret, the client random, and then the server random, and it generated a 48 byte random number. Okay. Now we generated this pre-master secret key. The master secret key has been received by both the guys. Once the master secret key has been received, now what the client does is the master secret key plus the random number plus random number, and it goes inside it, and then it generates the four session keys. So the same thing would be done by the server. The master secret key, the random number, which it would have generated, the random number which it would have got here, and it generates the 4 session key. And then the 4 session key would be shared across the browser and then the server. Now, once this master key and then the session key has been generated, the next important thing what happens is the change of the cipher message will happen. So this is like, hey server, let's now change the cipher what we negotiated above. So once the change of the cipher has been happened, then it will send the encrypted handshake message. This is like the encrypted. Here is the hash value that can be used, like it takes the hash value of the complete message, and here is the hash value that can be used to verify the exchange that I saw previously, and then I am done with it. So this is what it does, like the client key exchange, and then it sends the change cipher spec and then the encrypted hash message. Once this encrypted hash message is done, we are almost done with it. And then the server will also send the encrypted hash message. And once that encrypted hash message and then flows between the client and then the server, then any data which flows between the client and then the server would be encrypted. Saying this, I will end this session.